So if the hydraulic shape is what matters in the internals of a pump, and it does, you can see the Genesis series is known for its resin-rich surfaces, which provide ultra efficiency, up to, I want to say the 326's BEPs are up to 82, 83%. And smooth internal hydraulic passages account for that. The design of how the motor diameter, the eye fits around the inlet, there's a very tight tolerance there. Your collector and diffuser shape, the proximity of the OD to the pump cutwater, all those things add to efficiency. And the complex or tight design is really great for that. But what happens when you have an application where the enclosed impeller and efficiency, perhaps it's a intermittent duty instead of a continuous duty application, where efficiency doesn't matter as much, and getting the work done that's required of something like a semi-open impeller is what is needed. In those situations where you need to move solids or have a low shear component from the impeller, where something like in aquaculture applications where you're utilizing aquaculture feeds, rotifers, artemia, microalgae. I guess you could even go as far as biofuels, where you're trying to harvest something from a photobioreactor and you don't want to disturb any of the cellular walls and these biological solids that are suspended in fluids. A recessed impeller, semi-open impeller, meaning the impeller is recessed a bit from this collector and diffuser design in the volute. So a vortex is created in the hydraulic shape. And with that vortex, the majority of the fluidized solids or suspended solids will be displaced by the vortex being created from the impeller being recessed and the veins swiping, and you wouldn't disturb those particles that are suspended in the fluid as discussed. Additionally, in LSS applications, perhaps another intermittent service where it's a mammal exhibit, there's waste that collects in dead spots, maybe in pools, and a manual operation where it's a water vacuuming process goes to vacuum up the solids. That's done a lot of times with horizontal centrifugals, and a recessed impeller is also good for that, to process the solids out of a reservoir or tank exhibit and run them to waste. And that's where a recessed impeller really gets interesting, and that's what we're going to demonstrate here. So we still are keeping the same hydraulic shape out of the 326 standard parts here, volute bracket or seal chamber, seal housing, whatever name you want to give it. However, this is just a very, it's like a cross-sectioned part of the bracket, the normal bracket. So there's basically two brackets here, but one functions as a spacer to recess the impeller. Very simple when you're dealing with through-bolt designs. You can see in here that the impeller drops back and still has a little bit of vein exposed past the hydraulic shape, but not much. A good angle for that is here. You can look at it head on maybe, and you can just kind of see that there's just a little bit of tip of the veins exposed. Whereas if you were to look at how the enclosed impeller sits above the hydraulic shaping in the seal housing, it's much different and much higher. Well, this is exactly what will attribute to the vortex formed at the eye of the impeller that will help either not disturb biological solids or pass solids through the pump cavity.